Okay, guys, today we're going to talk about the periodic table, sort of the history of it and what it looks like today and how we use it. To start with, a very famous man, a very key man in chemistry, was Dmitry Mendeleev. He's the father of the periodic table. He was studying the elements. At the time, there were not as many elements as we have now, but he studied them. He determined their atomic masses and used things like their density, their color, their melting point, their boiling point, to organize them into a table similar to as we see today. He organized them in terms of their mass, and then grouped elements with similar properties like density and color and melting and boiling points together. And so he ended up with this nice organizational chart. And the most impressive thing about it all was that he left gaps for elements that were not even created. And actually, he was right about them. He predicted their atomic masses and where they fit in the periodic table before they were even discovered. So it's a very, very impressive system that he discovered. Our current periodic table now obviously is a lot more full. It can be defined, we have 119 elements that have been discovered or they feel are close to being confirmed. And they can be broken up into three distinct groups. So most of these over here in the blue and the pink, we consider them metals. Okay, and they conduct a lot of electricity and heat very, very well. They're malleable and they tend to be shiny in luster. Okay, the non-metals are up over here in the right, in green, often gases. Some are liquid at room temperature, but they're kind of the opposite, right? They do not conduct electricity or heat. They're very dull and they tend to be brittle. And last but not least, okay, are the metalloids. And they fall kind of between the metals and the non-metals. And often they're called semiconductors because they sort of conduct electricity, not as well as other things. And that's that orange staircase right here. So we consider this, we call that the staircase of the metalloids. It kind of separates the metals from the non-metals. Okay, now you've seen this before. I'm just going to review it. Okay, this is the individual squares that you deal with in the periodic table. Okay, so for example, the 54 is the atomic number, which if you remember is the number of protons and the electrons when it's an atom. Right, and that determines what element it is. The number of protons tells you what element it is. So the xenon here is 54 protons, so an atomic number of 54. In the middle, obviously the symbol, Xe here for xenon, and at the bottom, the atomic mass, which is the number of protons plus the number of neutrons. Now, this organizational chart, it's amazing in the sense that we can break it up in different ways. So as I showed before, the metals tend to fit over here, the non-metals up to the right, and the metalloids in that staircase. Now, as you look down at the bottom, they're also broken into families or groups. Okay, the first group here, the alkali metals, they're very, very reactive. You've seen one in sodium in a previous video that was very, very reactive. I've got a couple more videos. As you move down the alkali metals, they tend to get more and more reactive. So I'm just going to show you a couple videos here of, this is first potassium reacting to a little bit one further down than sodium. Okay, so you can see here, you get that spark and a little bit more of a reaction. Now, another move down, we're dealing with rubidium, atomic number 37, so there's 37 protons here, and you're going to see an even bigger explosion. So he's dropped this into water, and again, this is the reaction of rubidium with water. Significantly more intense. And then last but not least, we're going to see cesium, which again, one more down in that first group there, the alkali metals, the most reactive column, especially in terms of metals. So again, a very intense, huge explosion as you see the water going everywhere. Okay, so that's that alkali metals. The alkaline earth metals, also very reactive metals, not quite to the same intensity there. Okay, again, the transition metals, we'll talk a little bit more of them as you talk about senior chemistry. They're a little bit more unpredictable. Some are more reactive than others, and they all have different oxidative states. The noble gases, this is spelt wrong, but They're very important. You'll find that they don't react at all, very interestingly enough. But we still use them in a lot. Obviously, neon is one that you see a lot, or you've heard of a lot in terms of neon signs, but many of those noble gases are used in a similar way to give different colors. And the halogens, they pair up very well with the alkali metals, also very reactive. And we'll talk about why that is when we start talking about electrons. Okay, so the groups again we talked about are the columns here. So again, alkaline metals, alkaline earth metals, anything in the same column here, we consider that a group. And again, they have very similar properties because they have the same number of electrons. In contrast, you have periods, which are the rows in the periodic table, and they have similar arrangements. They have the same the sizes are very similar in this sense. Okay, so that's your periodic table presentation today. The next thing for you to do is answer the questions that go along with it on Verso. Thanks, guys.